Hello everyone, I welcome you all to JK Tech Solution YouTube channel. Today in our channel, I am going to walk you through the design of circular patch antenna using ANSYS HFSS. So before getting into our simulation, we need to know the basics of circular patch antenna. As you can see in the image, the circular patch antenna consists of three layers. The top layer consists of a circular patch, and the middle layer it contains a dielectric substrate. That is, here we are going to use FR4 epoxy as a dielectric medium, and the bottom layer we are choosing ground. So these are the three layers that are present in circular patch antenna. So there are different types of feeding techniques that we can use for designing circular patch antenna. We have two types of feeding techniques, that are contact feed and then in non-contact feed. In contact feed, there are two types, microstrip line feed and coaxial feed. And non-contact feed, you have two types, proximity feed and aperture coupled feed. In this video, we are going to discuss about microstrip line feed. So for calculating the design parameters of circular patch antenna, we have an online tool called antenna calculator.blogspot.com. I have mentioned the link in the comment section as well as in the description box. You can check it. I also mentioned the QR code in the screen, as you can see here. You can also scan the QR code and you can use the online calculator. So for designing 8.25 gigahertz frequency, we have taken the optimized radius as 4.575 millimeter and then the substrate length as 30 millimeter and substrate width as 19 millimeter. So these are all the design parameters that we have taken for designing a circular patch antenna. So now let's check with the online tool. So as you can see here, circular patch antenna calculator. Here you need to enter the frequency. You are going to design it for 8.25 gigahertz, and the dielectric constant value is 4.4 for FR4 epoxy, and the substrate thickness is 1.6 millimeter. Then you need to give calculate. So as you can see here, the patch radius we have got one substrate width. So here, if we want to calculate the feed line width and length, we have an EM talk. Okay, EM talks microstrip line calculator. Here you need to enter the epsilon r 4.4 and dielectric height as 1.6 millimeter, and the frequency we are designing for 8.25, and the Z0 value is 50 ohm, and the electrical length is 90 degree. Here you need to give synthesis. So for calculating the feed line width and length, we are using EM talk. So here the width is 3.0597 millimeter, and for patch radius here given. So now let's start our simulation. So after opening ANSYS HFSS, you need to click on HFSS. Solution type, here you need to give model. Then you need to give fit all. So first we need to create a ground plane. For that we are creating a rectangle. So here we need to rename the rectangle 1 as ground. So after renaming the ground, we need to assign the design parameters. So here the position is 0, 0, 0, and we have seen the X size, that is length of the ground is 19 millimeter, and then the Y size, the length, sorry, the X size is width. Okay, as you can see, the width is 19 millimeter, and then the Y size is length. The length is 30 millimeter. So as you can see here. So as we have discussed, the substrate length is 30 millimeter, substrate width is 19 millimeter. Okay. So these are the optimized values that we have taken. Okay, so these two substrate radius and then substrate width and substrate length are optimized values. Okay. So here we are giving the values and apply OK. So as you can see here, we have created the ground plane. The next we need to create a substrate. For creating the substrate, you need to draw box. So for the box, we need to assign the material as FR for epoxy. So whose relative permittivity is 4.4. So for the box, we need to assign the dimensions. So here the Z size must be 1.6 millimeter. So click on apply. Okay. So now we need to create an patch. Okay. So for creating the patch, trimetric, you need to draw a circle. At the center point, we can draw the circle. So for the circle, the radius is 4.575 millimeter. So the optimized radius that we have taken is 4.575 millimeter. So you need to click on apply. Okay. So now we need to draw the feed line. So for drawing the feed line, I think the feed line size must be larger so that we can move the circle. Okay. So instead of moving, I just assign the center. We can change the center position. Okay, so that we can assign the feed line. So the center position of the circle can be 9, minus 11, 1.6. Okay, we just check where the position. So now we have moved little bit the circle position. Okay, so that we can easily assign the feed line 9, minus 11, 1.6. So now for assigning the feed line, we are going to use microstrip feed line calculator. So as you can see, we have calculated 3.05 for 4.4 dielectric constant, dielectric 1.6 and frequency 8.25 gigahertz. And the Z naught is 50 millimeter, electrical length 90. So for that we got with us 3.05. Okay, roundly nearly we can take 3 mm. So for that we need to measure the position. So here the 8 mm is coming. Okay. So from the center we need to draw the feed line. So this is 50 ohm impedance, 50 ohm feed line. Okay, as you can see. So for the rectangle, as we have seen, the width is 3 mm, and then the length of the optimized length value is 10 millimeter. So click on apply. Okay. So as you can see here, we have given the feed line length and width. So the position here, it can be changed to 8. Sorry. So instead of 7.4, we can nearly change to 8. And then here we can change to minus 30 millimeter. And then here we can give 1.6 millimeter. The height must be 1.6. Okay, because above the substrate, we are going to place the feed line. So, okay, so height must be 1.6. So click on apply. Okay. So now as you can see the feed line. Now we need to, for matching the impedance, we need to draw the quarter wave transformer. For that, here in the online tool, you need to give the Z0, you need to change the Z0 value as 100 ohm. So after giving 100 ohm, you need to click on synthesize. So here you will get the width as 0.70. Okay, so this is the width. So now you need to draw the another rectangle for as a quarter wave transformer for quarter wave transformer. So now we can change the dimensions. So as you can see here, the width is 0.709. Okay, I have taken 0.70. 0.70 minus 0.70, and then the Y size here is 5.45. Okay, so the position can be 9.8, minus 20, 1.6 mm. So these are all the positions we have taken. So now we have give the quarter wave transformer. Now we need to merge the patch. So you need to click on circle 1. Then here I can rename rectangle 1 as feed line. and then the rectangle 2 as quarter wave transformer. So I just shortly mention as quarter wave transformer. Okay, quarter wave transformer. Just click on apply. Okay. I think it's not changed, so I just give shortly as QW. Okay, for quarter wave transform, I'm giving QW name. So now you need to merge the circle 1, then feed line, then QW, that is quarter wave transformer. Just click on unit. Now we need to give the feed line for an antenna. For that, we need to change the position to XZ. Then click the rectangle and draw here. So now we can rename it as input port. Now we can give the excitation for the input port. Assign excitation port, lumped port, 50 ohm as input impedance, new line. So here you need to click on center position, as you can see the triangle here. Then here. So the 50 ohm impedance line is defined. Click on next, finish. So now give fit all. So you can see the image clearly. Afterwards, change the position to XY. So now we have designed the patch and then ground plane as well as the substrate, and we have also given the excitation. Now our next step is to, as you can see here, the project 1, 2, we need to rename the file circular patch antenna. Okay, we have renamed. So now as you can see here, so we have assigned the excitation. So now we need to assign the boundary. Okay, for assigning the boundary, click on boundary. Sorry, you need to click on circle 1, right click on it, assign boundary, perfect E1. Okay, so now as you can see in the boundary, perfect E1 is assigned. Okay, so now next for the ground plane, we need to assign the perfect E. So click on ground plane, assign boundary, perfect E. So we have successfully assigned the perfect E for ground plane as well as the patch. So next we need to assign we need to create the open region. So click on right click and create open region. So our frequency here is 8.25 gigahertz. Okay, so click on OK. So vacuum layer is created. Next, we need to click the analysis. So click on analysis, add solution setup, advanced. Here our frequency is 8.25 gigahertz. Click on OK. Click OK. So now we need to check our design. So validation check. So all our design parameters are successfully verified. So now we need to, once again, we check the design parameters. Okay, correct. So now we can analyze our design. Click on HFSS, analyze all. Now the simulation is taking place. Simulation has started right now. Few minutes for simulation. now our simulation part is over. Now we need to check the results. So click on HFSS results, create model solution report, rectangular plot. So S parameter S1 dB. Now as you can see the result, click on marker, add marker. So we have obtained our result at 8.31. So nearly we have obtained our result at 8.31 gigahertz. So we have successfully designed. So again, click on HFSS results, create model solution report, rectangular plot. Now we can give VSWR dB. So now we can create marker, add marker. So 8.27. So VSWR plot, we have obtained our frequency at 8.27 gigahertz. Now we can calculate the bandwidth. So for calculating the bandwidth in marker. So now you need to click on add Y marker. So at minus 10 dB, you can calculate the bandwidth. So as you can see here at minus, still we need to maintain some accuracy. As you can see here at minus, exactly at minus 10 dB. So we have obtained our bandwidth. So you need to subtract the both values, so right hand value and left hand value, so that you can get the bandwidth. So here we have obtained the bandwidth nearly at 430 megahertz. Okay, so this is what the bandwidth that we have obtained. And next we need to check the gain plot. So for that, click on results, create model solution report. Sorry, create Fairfield's report, 3D polar plot, gained in dB. Click on new report. So here we have obtained a good gain plot at maximum range of 5.76. So here, finally, I like to conclude. Here we have obtained our frequency and our bandwidth at 430 megahertz, and we have obtained the VSWR plot and then the gain plot. So hence, we have successfully designed our circular microstrip patch antenna. Thank you so much for patiently watching to our video. In our next upcoming videos, we can discuss about the different feeding techniques that we have mentioned earlier. Okay, so we can discuss about the different feeding techniques for this antenna in our next video. Thank you so much for patiently watching to our video. I hope you to see you again on the next video. Thank you. Have a nice day.